So we'll just wait 5 minutes or so for others to attend. But thanks for joining us. We'll just wait a few minutes for people to have enough time to log on. So we'll just wait a few minutes to allow everyone a chance to log on. So there is a function on Zoom to ask questions for Q&A. So if anyone has any questions as we're going, please feel free to send that question through. And at the end, I'll have a chance to go through all of those. So if there's anything that I've covered that isn't clear or you'd like me to explain a little bit more, please feel free to send through a question. And there's also my email address, which is james@ortesi.com.au if you've got any questions that you want to email through down the track. So as I just said, we'll just wait a few more minutes to give everyone a chance to log on tonight. And as I said, there is a section in the Zoom menu where you can ask questions. So if anyone has any questions covering anything that I've gone through tonight regarding 3D printed orthotics, please feel free to send that through. And if there's anything else, my email address is james@ortesi.com.au. I'll show you that later on. And feel free to send through any emails that might pop up. So we might get started. I'd like to welcome you all. Thank you for attending tonight. What we're going to cover is Ortesi has just launched, as you've probably been aware, just over a week ago, our custom 3D printed orthotics, which we're really excited to bring to market. And I'm going to go through some of the different designs and also how to order those on our app. So the first design we have is our 3D printed smooth orthotic. And this is the most similar device that you're used to ordering, which is similar to our polyprope direct milled orthotics. The main advantage of these is you've now got the ability to vary the medial and the lateral flexibility. So these are really low fuss, low bulk orthotic, which if you have a look at it, you can see running down the middle of the orthotic, there is a structure core which we've created into all of our 3D orthotics. And that structure core is actually what when you're talking about the thickness, if you ask for a 3 mil device, it's the structure core running down the middle, which will be 3 mil. And then you've got the ability to increase the flexibility of either the medial or the lateral zone to varying amounts. So our structure core 3D, this is one of our more technically advanced orthotics. And what you can see is we use an advanced closed loop design, which alters the angle, the thickness, and the depth of the individual cells on the underside of the device. And by changing the cells on the underside, we're able to increase the flexibility and increase the stiffness as well without necessarily reducing the thickness of the device. So you've typically been used with a polyprobe device. If you want a thicker device, you increase the thickness, whereas when we are able to alter the geometry on the underside of the orthotic, which changes its mechanical properties. So one of the advantages of using the structure core and our other lattice-based 3D designs is that you're able to reduce effectively the weight of the orthotic without reducing its structural integrity or also its longevity as well. So you're probably used to, if you order say a 2.5 mil polyprobe device that's quite flexible in comparison to even just a 3 mil polyprobe. So by changing the geometry of the device on the underside, which we can easily do with 3D printing, we're able to increase that sort of structural integrity of the device. Our next design is the shock absorption 3D. And once again, this device also contains the structure core running down the middle. And it uses a unique Y structure, which the aim of that is to distribute shock away from the device and to incorporate that through the whole device itself. So these, once again, you've got the ability to change the flexibility of the medial and the lateral zone. And I think these are really good in terms of, they're a really durable device, our shock absorption one. So I think these are really useful for particularly work boots and any orthotic where you think it's going to get a significant pounding. These devices, the shock absorption one will have really good durability to it. Our lightweight lattice design is something that a lot of research and development has gone into. And there's been more than 300 revisions of the lattice structure to get it right and to get it to the standard that we're happy to bring to market. What we use with this is by using a unique lattice structure, we're able to reduce the weight of the device by up to 35% while still maintaining that structural integrity, which is important. So if I was to sort of sum it up, you probably find that with our lightweight lattice, there's probably a little bit more flexibility in it than you would. So if you order, for example, a 3 mil lightweight lattice, there'll be a little bit more flexibility than you're probably used to with a sort of standard 3 mil polyprobe. So we'll go next on to the app and I'll show you how to order our designs based off that. Okay. So I'm just going to share my screen. Okay. So everyone should have now received the latest version of Ortesi, which is version 1.4.0.0. This latest version will have this new section which comes available in the ordering section where you're able to order 3D printed orthotic. So you can see here that there's the 4 different designs you can request. We've got our smooth, our structure core, which has the closed loop structure, our shock absorption, and our lightweight lattice through there. So when you're ordering a 3D printed orthotic, effectively what we're doing is you can start off anywhere from 1.25 mil all the way down to a 5 mil device. And this is the core thickness. So that structure core that we were talking about that runs through the center of the device. So say, for example, I start with a 4mm device. Now have the ability to alter the flexibility of the medial and also the lateral zone on the device. So if you want the whole device, for example, to be, say we're using the structure core, and I want the whole device to be 4mm, what we're ordering is a 1-to-1 no change. So that device will be equivalent to a 4mm direct milled orthotic. If, for example, a common modification that people will add to an orthotic is a lateral plantar grind, and this increases that lateral column flexibility, which can sometimes help with footwear fit and also just reduce a bit of the rigidity from the device. You've got the ability to increase that flexibility now. So if we're using a 4mm device and you ask for 50% more flex, that lateral zone will be the equivalent of a 2mm device. And you can also, again, start off by, if you wanted to decrease the medial flex as well, increase that medial flex. You've got the option here to add a custom shoehorn. So there's varying, you can order a small, medium and large, and these are just similar to a regular shoehorn. They just come printed with we can also print your orthotic design onto that. And also to print your clinic logo. So we've also got the ability here to add your clinic name, which will be printed to the underside of the device. My advice would be if you're going to start if you're going to start increasing the flexibility of the different zones of the orthotic, I would generally order something which is a little bit thicker than you've previously been using. So for example, if your go-to polyprobe device is a 3mm device, if you want to start increasing that flexibility a little bit, I would start off using maybe a 4mm core thickness and then start off fairly mild in terms of increasing that flexibility, just so you get a bit of an idea of what sort of devices you're getting back and whether they're, have the right amount of flexibility that you're requesting. We can also add on here your clinic logo to the device. However, we can only do this on the smooth orthotic because that's the device where we've got enough space to actually print that onto it. So if you have a look on the new software that has become available, you've got all these "What's this?" buttons, and if you click on those buttons, it'll give you a bit of an insight. So with our to be able to print that logo, your clinic logo, it has to fit these dimensions, and it's best if it's a nice sort of solid sort of text. If it's got a lot of small writing in it, that often doesn't transfer very well. And if you're wanting to get that clinic logo printed on it, we do have an information sheet which will sort of tell you which logos will tend to work better, the dimensions, and the files that we want. So if you're going to send them through as a JPEG, we need a significant, a high quality file will tend to transfer a little bit better through there as well. So that is if we're looking at, there's probably a few differences between the different designs. I generally find with the smooth and the shock absorption, they will tend to be probably a slight bit more rigid than the structure core and the lightweight lattice. I would say that overall the lightweight lattice probably has a little bit more flexibility in it. So for example, I've got a few designs here. This, just holding up in front of you, you won't be able to see the underside very well, but this is a lightweight lattice and this is a 3mm device with 10% more flexibility on the medial and also the lateral zone. And you can see there that there is still a significant amount of flexibility in this device. So I would generally say with the lightweight lattice to maybe increase, if you're used to prescribing, say, a 3mm device, maybe start off prescribing a 3.5 or a 4mm device, particularly if you want to increase that flexibility medial or laterally. In comparison, you've got, this is one of the shock absorption ones, and this is again a 3mm device with 10% more flex medial and laterally, and this device is sort of a little bit significantly more stiffer than the lightweight lattice, but it still has a reasonable amount of flexibility to it. So just when you sort of start ordering, I would say that our smooth standard and our shock absorption will probably be the more, as I said, a slightly bit more rigid. You've also got the ability to click on the What's This app, and this will go through the various cell structures if you want a little insight when you're ordering the device. So if you have a look here with our smooth orthotic, the vinyl 11, which we use to 3D print the orthotics, is probably slightly more rigid a material than polyprope. So a 2.75 mil smooth is similar to a 3 mil direct mill polyprope. Whereas with the other ones, I would generally say that they're fairly equivalent if you're going that one-to-one. One-to-one, no change in terms of flexibility through there. So probably to sort of sum things up, when you're ordering devices, the main difference that we've got with a 3D milled orthotic is our ability to change the geometry on the underside of the orthotic. I'm going to just resume. Pop through to our presentation through here. There we go. So as I was saying, just to sort of sum things up, we've got our smooth 3D, which is again most similar to our direct milled orthotic. Our structure core, this is our one that's using a closed cell design. Again, you've got that ability to change your medial and lateral zone as you can do with all of them. What we're doing with 3D printed orthotic is, again, we're improving that structural integrity by changing the geometry on the underside of the orthotic. Our shock absorption 3D has a unique Y structure on the underside, which is has been put in there to improve its shock absorption and distribution. And our lightweight lattice, which gives you the ability to reduce the overall weight of the device. So this would be particularly useful for, I think, athletes, particularly where you want some flexibility in the device, triathletes, people that are doing sort of long distance type stuff, where you want a device that's fairly flexible, but is also quite lightweight, and you're not prescribing a very bulky orthotic in that case. So that's sort of running through how to prescribe the orthotics and how to do that on our app. Is there any questions that anyone has regarding that? Let's bring that back up. See if there's any questions. Okay. No. What I might do as well, we've got a little bit of extra time, so I'll just go through the new app and some of the features that we have through the new app. The new app you'll see here, we've got at the moment we've got detailed prescription, which is your traditional prescription that you're used to. Coming soon, we're looking at doing a guided prescription, which will use an algorithm. You'll be now used to, there are certain, all of the fields now are mandatory in terms of weight, age, shoe size, and that becomes more important when we start using a guided prescription form. When we move through to here, we've got our different arch high points are all the same. Our arch height is also the same. So when you're prescribing an orthotic, if you're looking at a standard arch, that is basically saying that as they're about to design the orthotic, before any corrections added, the device will basically be 85% of their arch height, and then the correction is added on top of that. So generally, depending on the different designs, if for every degree of correction, we're going to get an increase in the arch height by approximately 1 mil to half a mil. When we Press through here, you've got your different cover lengths. You can also click on here to trim to shoe size. So if you've, which is why it's also important that when you have put the patient's shoe size in properly, because that's the size that it'll be trimmed to. And as you're aware, probably this is really important for a EVA orthotic to use the trim to size A, B, C, and D length. So the A is the diameter, the width of the heel, the B is the width of the arch, C is the width of the forefoot, and D is the total length of the device. So that if you're prescribing a full-length EVA device, that you get a nice fit, particularly if it's going into, that you're not having to cut or trim that at all. Let me move through to the next. Again, you can see on here with the What's This app, you've got all your various premium pour-ons that come up there and the different properties that they will, that you have. So you've got your different pour-ons which you can have a look through. I'm just going to progress through to the next. So you can see here that it's very sensitive. If you've got on here trim to A, B, C, D, it's not going to let me progress to the next stage. Here again, we've got a lot of this will look quite similar. So with our first ray cutout, our first ray accommodation. A first ray accommodation is really similar to a first ray cutout, just the device will actually, the shell will still, although it drops away a bit steeper than on a standard device and is a little bit shorter under that first ray, it still makes contact. So if you've found in the past that a first ray cutout can make the device a little bit unstable, with a first ray accommodation, you're achieving the same sort of functional result, but the device will tend to be a little bit more stable if you haven't put a post on it. We've got our various posts, so full, half medial, half rear, quarter post, and you can request those, which previously you had to actually type it in. If you hit an intrinsic post, for example, you'd have to actually put in the notes, a half medial post. That option's now available as you're going through the prescription form. So the benefit of our new app is that really with all of these, you can have a look at the various designs. So all our met domes, you can see here, you can get the dimensions, the height of the orthotic of the met dome. And if you're asking for a medium one, that will be the sort of the dimensions that you're going to get. So the more specific you are with your prescription, obviously the better. I'll see if there's any questions that have come through. Doesn't look like it, but overall, prescribing a 3D printed orthotic is not too dissimilar to prescribing how you're used to. Our designs are really all the same. The main difference is you have that ability to change the flexibility in our different zones. A general rule for that is in areas where there is, what you tend to find clinically is in areas where there is instability, you'll get a shift away from those zones. So for example, like with HAV, you'll tend to get decreased loading under that medial column as people shift away from that. So a general rule that I tend to stick with is in areas where there's instability, you tend to want a bit more stiffness in those areas. And in areas where there's a lot of rigidity, you can get away with more flexibility in those areas. So that's a general rule that I use when prescribing a 3D printed orthotic with our new feature to be able to do that. So, as I said, if there's no questions that have come through, that will really conclude tonight. If anybody has any questions that they want to send through, my email address is just down there, which is james@ortesi.com.au. We've got a question here. So we've got a few questions. Ben has asked, can you have the medial or the lateral side thicker than the core? The answer is no for that one. What I would generally suggest is that if you want to alter that flexibility, go with a thicker core, and then what you can then do is drop that down again. So for example, if you were to ask for a 5mm device and then you were asked for 50% more flexibility in the lateral zone, that lateral zone will be the equivalent to a 2.5mm device. Another question that we've got is, can you do a deflection on a 3D device? Can I just ask, by deflection, do you mean a sort of an accommodation, a hotspot accommodation? So if that is, yes, an accommodation for prominence, yes. So what we're looking for is to accommodate a prominence. The way I would request that is to ask for a hotspot prominence, and I would mark that on the patient's foot. So if you're using a 3D scanner, an iPad scanner, or if you're using a cast, to actually mark it onto the cast. So, and it has to be fairly visible. So either a sort of a more of a whiteboard marker or something along those lines, or even a large sticker, and mark that on, and you can specify that, you know, please accommodate as indicated on the scan, and also ask for the depth that you want that accommodation. So if you want it to accommodate 3mm into the shell, then we can also do that. So yeah, we can definitely accommodate on a 3D device. Beth has just asked whether 3D devices can be modified on the grinder or heat molded. They can be modified on the grinder. You can also heat mold them as well. They're probably a little bit different to polyprobe, but in terms of heat molding it, I have heat molded a few of them, and you do have that ability to do it, but it probably doesn't work as well as it does with polyprobe. But you can definitely grind posts and things like that. That's not a problem at all. They'll be able to modify really similar to a polyprobe device. Perfect. Might be hard to get a smooth finish on the grinder though. So Beth has just stated that it might be hard to get a smooth finish. I think with regards to the finish on the grinder, it depends what you're grinding. If you're grinding a post, you'll get a nice finish. However, what I'd recommend is, one thing that you're not really able to do, you can do it, but it will damage the device, is if you're previously used to grinding, like the medial arch on the device, then if you're using particularly any of the structure core, the shock absorption, or the lightweight lattice, if you grind that underside of the device, you're going to change its structural integrity significantly, and it's not going to be a very nice finish on it. So that's why I would suggest that if you're prescribing for someone where potentially it's a more rigid pes cavus foot type and you're worried that there might be some medial arch irritation, I would just ask for an increase in flexibility to save yourself having to modify that at all. So Rob has asked, so you can't have an equivalent polyprobe device with 2.5. So you've still got that ability. You still have the ability, if you do want, for example, the medial to be stiffer or the lateral to be stiffer, if you still add things like cuboid notch or you can still also ask for a lateral rib, like you've used for a sort of forefoot valgus. You can still ask for those things. We can still stick things on the bottom. You know, if you want a plantar fascial groove, that's still going to increase the stiffness of the medial column. So you can ask for those same features, yeah. We'll be able to design those into the device. Perfect. Yeah, so as I was just sort of mentioning with that question there, for example, if you want to, so the original question was, it could be, can you increase the stiffness, say, of the medial zone or the lateral zone greater than the core? And the question is yes, but the way to do that is to do that with an addition. So, for example, a plantar fascial groove would increase that stiffness. You do also have the ability to put basically a medial bar on the device or a lateral sort of bar on the device, which runs on the underside, and that will increase the stiffness of that zone as well. So, perfect. Do we have any other questions? We'll be running a few of these webinars. There'll be another one in 2 weeks' time. We are also offering as well, so if anyone has, in terms of from a clinic point of view, we're running, if you contact me via email or contact the lab, they can put you in touch with me, where particularly things with scanning and orthotic modifications and general prescription Zoom conferences we can do. So if as a clinic you've got a few podiatrists, or even just personally, you'd like to go through the prescription form, go through 3D scanning, that's something that we can organise and schedule a date to do that, which is probably a bit more personal than a webinar, which we can more workshop specific problems that you would like to work through in terms of trying to get the devices that you're wanting for your patients. So on that note, if there is no more questions, that will sort of conclude our 3D printed orthotic webinar. So thank you all for attending tonight. And as I said, if you've got any questions, please feel free to email me through on the email just listed below. Enjoy your night.